Hi students, this is lesson 2.2 and we're going to go ahead and get started here. Let's see. Sorry. Okay, our learning goal today is I can find angle measures and side lengths of non-right triangles using the law of sines and the law of cosines. Now we're actually going to prove these laws, but for today I'm just going to give them to you and we're going to try to use them. The criteria for success when we're solving a non-right triangle is we're going to choose the appropriate tool for solving the triangle. We're going to substitute values correctly, and then we're going to solve for all missing angle measures and side lengths. So this is in your PDF on page. Go ahead and label this triangle. Really exciting here, A, B, and C for our three angles. And then for our three sides, across from angle A would be side A, across from angle B is side B, and across from angle C is side C. Okay, now our law of sines, we're going to start with this. And for this one, what we're going to use, let's just get a different color here. We're going to take the sine of angle A over side A. That's equivalent to the sine of angle B over side B. And that's also equivalent to sine of angle C over side C. Again, we're going to prove why this works, but for now, if you have one side and two angles, you're able to go ahead, set up a ratio, and solve. And we'll do some practice with this to show you how. Okay, law of cosines. So law of cosines is side C squared equals the sum of the squares of the other two sides, so in this case A squared and B squared, minus 2AB, again those other two sides that I didn't square in the beginning, the C, and then cosine of angle C. Now this follows for all three of the different angles, so we can also say side B squared equals A squared plus C squared. Notice these are the other two sides I didn't use. Minus 2 times these two sides, AC, cosine of angle B. And notice this is going to match what we have over here. Okay, so for all of these, that's going to actually match. And then we have side A squared equals the other two sides, B squared plus C squared minus 2BC cosine of angle A. So honestly, if you know one of the law of cosines, you'll probably be able to notice that pattern and you can replicate it with any of them that you'd like. And the same thing with the law of sines. So we will prove it. We will try to understand why these work, but for now we're just going to practice using them. So let's go ahead and get started. You will definitely need a calculator, and you will have to be very careful with your order of operations. You will also need to be, in this case, in degrees. So please make sure your mode is in degrees. Okay, we're looking on page 29 in the PDF or the packet, and we're just going to do a couple of examples. So example 1 starts off giving us two angles and a non-included side, that 56 side C. Okay, so in this case, it looks like we could go ahead and do law of sines because we have this angle and opposite side, and then we have this angle, and we would be missing this side here. So we want to solve for all the missing pieces. So that's one way that we could get side A. The other thing I know that we can do would be to find the measure of angle B. So I'm going to write this out. Measure of angle B equals 180 degrees minus the 46 minus the 63, because we know the sum of the angles in a triangle is 180 degrees. So the measure of angle B is 71 degrees. So we can go ahead and put that missing angle. So that's one of the pieces we need to find. Now the next piece is side A and then also side B. So let's go ahead and find side A. So I'm going to use sine of angle 46 degrees, that angle A, sine of 46 over A, we don't know that, is the same as, let's do sine of 63 degrees over the opposite side of that, which is 56. Okay, so now I'm going to start showing my solving steps. The A is kind of buried right now, so I'm going to undo the dividing by A by multiplying by A. When I have an A up top and on bottom, that's just like saying A divided by A, which is 1. And so my next line is going to say the sine of 46 degrees equals sine of 63 degrees over 56 times A. Now, if I want to, I can just multiply by the reciprocal to get A alone. So we can actually multiply by 56 over sine of 63, multiply by 56 over sine of 63. So in this case, these cancel, and now I am left with just plain old A, which is what I wanted. It'll be, whoops, yeah, that's what I wanted, 56 sine of 46 degrees over sine of 63 degrees. So let's go ahead and put that in the calculator, and I'm going to double check my work here and make sure you are in degrees. And so we should get for this, A is approximately equal to 45.211 degrees. And we do want to, oh, I'm so sorry, this is not degrees at all. This is a side length. Pardon me. So this would be units. It doesn't tell us what the units are, so we can just write units, that's fine. So that's side A, which is right here, 45.211 units. Okay, so the last thing we need to find is side B. So I'm going to go ahead and use law of sines again. And there's no perfect way to do these problems. So you're gonna try different things to solve, and many ways are going to be able to be correct. Sine of 71 degrees over B equals, and I guess I'm just going to go with the C. So sine of 63 degrees over 56. You could have just as easily done sine of 46 over the 45.211. The reason I'd rather not use that is because I may have made a mistake, and it's also a rounded value, and I want to have things as exact as possible. So I definitely would prefer to use the given exact values. Okay, I'm going to multiply both sides by B to get that B unburied from here. Oops. And so I'll have sine of 71 degrees equals sine of 63 degrees. What the heck is that? Let's try that again. 63 degrees. There we go. Over 56 times B. And then in this case, I'll go ahead and multiply both sides by the reciprocal to get B alone. So 56 over sine of 63 degrees times 56 over sine of 63 degrees. From here, we're able to do some canceling. So the 56 and the 56, sine of 63, sine of 63, and finally B is alone. So 56 times sine of 71 degrees over sine of 63 degrees. Again, I'm going to go ahead and check mine to make sure everything is okay. And we will be moving into radians, but for now, still degrees. Okay, so B is approximately equal to 59.426 units. And that's going to be our final value here, 59.426. So solving a triangle means we're going to identify all three angles and all three sides. Okay, let's look at the next one. So this is actually on your PDF page 30, and we're going to look at example 1 and 2. And let's see what we can do. So in this case, we're given two sides and an included angle. So let's see here. Yeah, we're going to have to definitely use law of cosines in this case. So let's think about an angle that we want to find here. So let's try to find maybe angle B. So let's take a look for this one first. So we would then say 20 squared, that's the side across from the angle B, equals 30 squared. Oh, hold the phone, I can't do that. So if you see what I was just trying to do, 30 squared plus a squared, and then I also have an angle B, so that is going to be a problem. We can't do all that at once. We do have the angle 60, so instead, let's start with that. So this might happen too. You're going to try something, and if you have more than one unknown, you're going to have a problem. And that'll tell you that you need to try something else. So if you do make that same mistake, you can go from there. Okay, so I'm using angle A and side A. So I'll say side A squared equals the other two sides, 30 squared plus 20 squared, minus 2 times 30 times 20. And then we want cosine of 60 degrees. Okay, that works out much better. Notice we're just missing that A, and we can go ahead and solve. So we'll go ahead, and you should be doing the same calculating here, doing your order of operations. We should get 1300 minus 1200 cosine of 60 degrees. And you can always pause me to make sure that you are following along. In this case, I get a squared equals 700. And in order to get a, I would have to take the square root of both sides. When I do that, I get a is about equal to plus or minus 26.458. Now, of course, if a is a side, it will be only the positive as our final answer. But algebraically, there are two answers. Okay, now I have side A. So now let's try to find another piece here. So let's try to find angle B. Let's try this. So if we want to try this, let's get this kind of out of our way here. We would have 20 squared equals 30 squared plus 26.458 squared. Now in this case, we don't really have much of a choice but to use that rounded value. So again, if I can help it, I don't want to, but if I can't, then I just have to use the rounded. Minus 2 times 30 times 26.458. I'm running out of space. Cosine of B. Now notice, angle B is my only unknown, which is great. So that means I can go ahead and solve. So we're going to have 400 here on the left. We're going to have, and there's some rounding here, but 1600, and then we have 0.026 minus 1587.48 cosine of B. We're going to go ahead and subtract and divide, and what we should get is 1200.026 over 1587.48 is equal to the cosine of B. So I subtracted this, and then I divided by this value here to get cosine of B alone. Now, we don't want cosine of B, we want just B. So we are going to take the inverse cosine of both sides. This undoes that cosine and leaves us with just a B. So when I calculate this, B is approximately equal to 40.893 degrees. So that would be our B, 40.893 degrees. Okay, last thing to find for this is angle C. Now in this case, since we have the two angles already there, we can go ahead and do our subtraction from 180. So we can go ahead and say measure of angle C equals 180 degrees minus 60 degrees minus 40.893 degrees. And the measure of angle C should be about equal to 79.107 degrees. Most things in life are going to be quite messy. So expect things to turn out a little crazy. Our right triangles turn out pretty usually, but these oblique triangles are going to be a little bit crazier looking. Okay, example 2 on that same page. This one we're given all 3 sides. So we really can pick whichever one we want to start with to find an angle. So I'm going to go ahead and find angle C, which means I'll take the side across, 9 squared, equals the square of the other 2 sides, we're adding those together, minus 2 times those 2 sides, minus 2 times 6 times 4 times cosine of C. We'll go ahead and do our order of operations. Definitely use that calculator. We do not have to do everything by hand. We should get 36 plus 16 minus 48 cosine of C. So in this case, we'll end up subtracting 36 and 16 from both sides, and we should get 29 equals negative 48 cosine of C. We divide both sides by negative 48. 29 over negative 48 is equal to cosine of C. We're showing all our steps. And now we need to take the inverse cosine of both sides. Okay, so we get C is approximately equal to 127.169 degrees. So that's what's right in here, 127.169 degrees. Okay, from here, let's think about what we want to do. We're going to have to actually do another law of cosines to find one more angle. After that, we can just use the sum of 180 and just take away the 2 angles we know. So we'll do this one more time. Let's go ahead and find angle B. So for angle B, we know that this is the side across. So we'll start with 6 squared equals the other 2 sides. So we'll have 4 squared plus 9 squared minus 2 times 4 times 9. Notice that pattern that keeps happening. Cosine of that angle B. And we're doing the same thing here. We have 36 equals 16 plus 81 minus 72 cosine of B. We're going to go ahead and subtract 16 and 81 from both sides to get negative 61 equals negative 72 cosine of angle B. We divide both sides and we get 61 over 72 is cosine of angle B. And now we will go ahead and show that we are taking the inverse cosine of both sides. So this leaves us with angle B, which is approximately equal to 32.089 degrees. 32.089 degrees. Okay, the last part of this is the nice little part at the end where we say measure of angle A has to be 180 degrees. Take away the 2 angles we just found. 127.169 degrees and take away 32.089 degrees. So the measure of angle A is going, and I want to say approximately equal to, is approximately equal to, because of course we're doing quite a bit of rounding here, 20.742 degrees. 20.742 degrees. Okay, so this is how we're going to go ahead when we have non-right triangles. We have some new tools that we're able to use to solve for missing angles and missing sides. So you're going to go ahead and try these. This one, angle A is 35 degrees, angle B is 15, and side C is 5. And then number 2, we have 3 sides. Side A is 6, side B is 5, and side C is 8. So you're going to go ahead and pause. I'd like you to set these up and solve. Okay, and I think what I'm going to do is when I post these slides for you to view, I'm going to post the answers actually within that so that you can go ahead and check them when you are done. All right, good luck, and I will see you in class soon.